Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Hmm. I think you can see clearly now. Okay. So our course, this is our course outline. We are under the College of Engineering and Technology. Our course code is CSC-329 and course name is Logic Design and Switching Circuit. So, okay, when I will supply this course outline, all of you will read this course details. Our textbook's name. So, everyone writes the textbook's name. Our main textbook by M. Morris Mano and Michael D. Clage. The book name is Digital Logic and Computer Design. Can you hear me, everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
This is our textbook. Okay. So I have the soft copy. I can provide the soft copy to all of you. But till now, I will not provide any soft copy. Whenever you will filter the group members and you will submit me the report that yes, ma'am, nobody is from outsider, then I will submit these copies. Got my point? The fear?
Yes, ma'am.
Okay, so if you can collect the hard copy, that is very good, because maybe your university will be open. That times you have to bring the hard copy. Okay, so if you can collect the hard copy, if you can collect it, that is the best. And if you cannot collect the hard copy, collect for right now. Collect the soft copy.
Ma'am, maybe I have the soft copy of this book.
Okay, but don't share in the group.
Okay, ma'am.
At first you will filter out, then you will share it. I also have the soft copy of the book.
Okay, ma'am.
Okay, clear everyone? So have all of you written the name, textbook name and writer name?
Yes, ma'am.
And whenever you will do my class, everyone keep a pen and a notebook with you. I will give you sometimes to write some things. Okay? And about the classroom, everyone please when you are entering, check your name and ID. Write your name and ID properly in your Zoom platform. And give your formal photo. Clear everyone? And when the
Yes,
attendance,
ma'am.
when I will take the attendance, that attendance time, you will turn on your video. I want to see your face. Okay? So this is our grading policy. If you got greater than or equal to 90, the grade will be A. That's 87 equal to less than or equal to 89. Then from 87 to 89, B plus. 84 to 86, that is B. 80 to 83, B minus. 77 to 79, C plus. 74 to 76, C. 70 to 73, C minus. 65 to 69, D plus. 60 to 64, D. And below 60, that is F. Okay? This is the grading policy. This is the academic offense. You'll read it. I can give you homework, exercise, or anything. This is our course outcome and program outcome mapping. This is our program outcomes. For engineering, there have 12 program outcomes. These are the Bloom's taxonomy. These are the affective domain. If you don't understand, no problem. This is not for you. This is our lecture plan. Okay? Lecture plan. So we did orientation. Now today we will learn Introduction to digital systems. Define the analog and digital system. Difference between analog and digital system. Determine advantage of both of them. Okay, today we will read it. So let's go for our lecture. Lecture 1, analog system versus digital system. Okay, everyone. Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everyone in your script, write give today's date. Today's date is 26 January 2021 and write the topics. The topic's name is digital and analog signal. Okay? So today we will learn digital and analog signal. Can you see my slides?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
So at first we will learn what is signal. So what is written here? Everyone concentrate please. A signal is an electromagnetic or electrical. So electrical is known as the electromagnetic. The term electrical means electromagnetic. Okay. Current that is used for carrying data from one system or network to another. So this is basically a signal. What is basically a signal? When the electrical current will be used for carrying the data from one device to another device, that time the electrical current will be called as a signal. Got my point?
Yes, ma'am.
What is signal?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
So what is signal? Signal is not only electrical current. So electrical current can be used for many work. Electrical current can be used for different device, different purpose. Suppose electrical current used for brightening a light, turn on a light. Electrical signal can be used. Electrical current can be used for turning on a fan. Electrical current can be used for turning on a device. But when the electrical current is used to carry the data from one device to another device, that time it's called as a signal. So now you can tell what is signal if I ask.
Yes, ma'am.
If electrical current used for carrying data from one
For
system to
carrying
another.
data, yes. That means we use electrical current for different purpose. We can use the electrical current for different purpose. But when we will use the electrical current for carrying the data, that times it will called as a
Signal.
electrical signal or simply signal. Okay, so signals are two types: digital signal and analog signal. Let us see. And electronics and telecommunications, it refers to any time varying voltage that is an electromagnetic wave. So now the question may come, what is electromagnetic wave? Already you read it in the FEDS subject or in the physics. You read it already, electromagnetic. So again I am telling you, in electronics and telecommunication, it refers to any time varying. There have some time variation. Okay, any time varying voltage that is an electromagnetic wave which carries information. A signal can also be defined as an observable change in quality, such as analog signal and digital signals. So signals are two types: analog signals and digital signals. So let's go for the next slide. What is analog signal? So you can see, you are familiar with this sign, is not it?
AC current. Yes, ma'am.
This is positive half cycle, this is negative half cycle. The lower one is negative half cycle, upper one is the positive half cycle, and fully this is a full cycle. Okay, so this kind of signal is known as the analog signal. See, there have some volts, amplitude and time. Okay, an analog signal is one type of continuous time varying signal. Time varying, that means due to time this will vary. See, this is time is going, and that is going upper side and lower side, upper side and lower side. Okay, and these are classified into composite and simple signal. This is a simple signal. What is composite signal? Composite signal means when you are compiling two or more simple signals, that times it will be the composite signal. A simple type of analog signal is nothing but a sine wave. This is a sine wave, and that cannot be decomposed. Whereas a composite type analog signal can be decomposed into numerous sine waves. This is a sine wave. So the analog signal looks like this one. So there have a time variation. See, from starting to this positive half cycle, there have a time variation. From this positive half cycle to end of the negative half cycle, there also have a time variation. So they are saying this time variation. Now we have to understand about everything of the analog signal. Okay, this is a wave. The signal, basically the analog signal is a wave, sine wave. So this side, the vertical side is displacement. Okay, so you see this sign lambda. You are familiar with this term, is not it?
Yes, ma'am.
Yes, ma'am.
Can you tell what is the name of this sign?
Ma'am, lambda.
Lambda, yes. What do you mean by lambda? Can someone tell me?
Wavelength.
Wavelength. Already we know, we read it in the physics in class 9, class 10 and the 11 and 12, and also in our university physics subject. Okay? So I think we have no need to explain it more. So lambda is means wavelength. So say the mark, this is the wavelength. This is the neutral point. From the neutral point, how much highest point the wave will go up, then after that it will again decreasing. This length is called the wavelength, and the wavelength is notified by the sign lambda. Okay, and this is why we are denoting y as the amplitude. Okay, what is amplitude? Amplitude means from this highest point to highest point, this length, this measurement from this highest point to this highest point, this is called amplitude. Observe this one. Observe the right side picture. What is wavelength? Distance between identical point one consecutive waves. So this is the green sign. The green sign is called lambda, wavelength. Okay? Amplitude, distance between origin and crest or throw. This one is amplitude. Okay? Frequency. Frequency means number of waves that passes a point per unit of time. So the frequency, the unit, the formal unit of measuring a frequency is second. So you can find it out also per minute. You can say the per minute the frequency is this one. That means per minute or per second how much wave you are getting. That is called the frequency. Frequency is known as V. Then is speed. Speed is calculating. Speed is equal to wavelength multiply frequency. Clear everyone?
Yes, ma'am.
Clear about the analog signal? Do you have any question about the analog signal?
No, ma'am.
No.
No, ma'am.
Okay, so we can go for the next slide. Analog signal, that is written here. An analog signal can be identified by using amplitude, time, by using amplitude, time period, otherwise frequency or phases. Amplitude strikes the highest height of the signal, frequency. So you will read all these things. Whatever I told in previous slide, the description is written there. Okay. So the analog signal or value range cannot be fixed. That means that will sometimes you can go too much upper, sometimes little bit upper, sometimes too much upper, sometimes little bit upper. Okay. So that cannot be fixed. You have to remember these points. The analog signals. These are the features of the analog signals. Now, these are also the features of analog signals. An analog signal is a continuous signal, whereas digital signals are time-spreaded signals. Analog signal is denoted by the sine wave, while it is denoted by the square wave. So there have analog signal versus digital signal, some points. Okay. So analog signal uses a continuous range of values that helps you to represent information. On the other hand, digital signals uses discrete values 0 and 1 to represent the information. Okay. Analog signal bandwidth is very low, while the bandwidth of the digital signal is high. Analog instruments give considerable observational errors, whereas digital instruments never cause any kind of observational errors. Analog hardware never offers flexible implementation, but digital hardware offers flexibility in implementation. Analog signals are suited for audio and video transmission, while digital signals are suited for computing and digital electronics. Okay. There have some difference between analog versus digital. So at first we will read the digital, then you will be able to understand this difference. These are the characteristics of analog signals. Here have some essential characteristics of analog signals. These types of electronic signals are time varying. Time varying means that will change through the time. Okay. Minimum and maximum values, which is either positive or negative, because we have seen in the picture that it has positive half cycle and negative half cycle. It can be either periodic or non-periodic, and that means after a certain time, this line means after a certain time, it can be changed or it cannot be changed. The wavelength or wave amplitude, everything will be same. Okay, that means for a fixed time period. Okay, so analog signal works on continuous data. The accuracy of the analog signal is not high when compared to the digital signal. It helps you to measure the natural or physical values. Analog signal output from is like curved line or graph, so it may not be meaningful to all. Next, now we will read about the digital signal. Okay, so a digital signal is a signal that is being used to represent data as a sequence of discrete value. What do you mean by discrete value? Discrete value means the specific value, exactly value. In analog signal, we have seen, is there have any exactly value? No. We are saying that wavelength or amplitude may vary. Sometimes on the time change, with regards of the time change, it can be upper, it can be lower. Okay. But in digital signal, the signals will be represented as a discrete value. That means the value will be only two values, 0 or 1. At any given time, it can only take 1. That means at a specific time, it will be only 1, either 0 or 1. At most, one of the finite number of values. This contrasts with an analog signal. This is contrast. Contrast means opposite, which represent continuous values, but in digital signals, it is represent the discrete values. Okay, at any given time, it represents a real number within a continuous range of values. Now observe this picture. A binary signal, also known as a logic signal, is a digital signal. So a digital signal has two another different types of name. Digital signal also is known as a binary signal, also the logical signal. So if I ask you what is binary signal, so can you give answer?
Ma'am, 0 and 1 signal, ma'am.
This is not the definition. Okay. So if I ask you the definition for binary signal, if I ask you the definition for logical signal, if I ask you the definition for digital signal, all the answer will be same. Okay. Digital signal is known as logical signal, as also the binary signal. Why this is called binary signal, the digital signal? Because in the digital signal we represent the value with binary values 0 and 1. That's why the digital signal is known as a binary signal with two distinguishable labels. Two labels, 0 and 1. Observe this one. This is time. They are taking the time as second. This is the amplitude. Okay, amplitude taking as the volt. So suppose this is 1 and this is 0.5 amplitude. This is 1, this is 0.5. Okay, and this is the neutral point. Okay, observe 0 volt, this is plus 5 volt. Observe in the digital signal the line does not go to the below, but in the analog signal there was positive half cycle and negative half cycle. Observe when this is 0, when this is 0, our line is here. That means in the lower portion. When our signal is 1, when our signal is 1, our line is here in upper portion. Okay, again 0 0, that means 2 in 2 time slot the output was 0. After that we get 1, then 0, that means 0 level 0, output was 0. Then 2 1, that means the output of upper level, suppose 5 volt, 5 volt. This is 5 volt, this is 0 volt. Okay, so at first, in first second the output was 0 volt, in second output was 5 volt, then third second output was 0 volt, fourth second 0 volt, after that 1 volt, 1 means 5 volt, 0 volt, then 5 volt, 5 volt. So did you understand how to represent the digital signal?
Yes, ma'am.
Yes, ma'am.
Okay. So in the digital signal only 0 and 1 representation will be there. 0 means lower value, 1 means upper value. These are the characteristics of digital signal. Here are essential characteristics of digital signals. Digital signals are continuous signals. This type of electronic signals can be reprocessed and transmitted better compared to analog signals. Digital signals are versatile, so it is widely used. The accuracy of digital signal is better than that the analog signal. These are the advantages of digital signal over the analog signal. Okay, the comparison is over the analog signal. There are several advantages using digital signal over analog signal. Digital signals are more secure and they do not get damaged by noise. So noise means, what do you mean by noise? Do you have any idea about the noise? Noise means ki?
Ma'am, does when the signal flow, it makes sound?
No, this is not that type of noise. Okay, so I am telling you, noise means the another wave. Suppose you are sending a wavelength, but in the air only your wave is not there, is not it? Suppose you are sending one wave, I am sending another wave. So your wave your wavelength or your wave is noise to me. Got my point? Suppose two devices is sending two different waves through the air. Okay.
Yes,
So
ma'am.
the another device wave will be noise to my device. Got my point?
Yes, ma'am.
That is called noise in noise in the electronics area. Okay. So they are saying that noise can affect the analog signal, but noise cannot damage the digital signal. That means if your noise is affected, if your analog signal is affected by the noise, your signal quality will make change. But in digital, this cannot be changed. These signals use low bandwidth. For the analog signal, you have to use high bandwidth. They allow the signal transmitted over a lengthy distance. That means you can send it very lengthy area through digital signal, but maybe less lengthy area through the analog signal. By using these signals, we can translate the messages, audio, video into device language. Digital signals enable the transmission of multidirectional currently. Got my point? Multidirectional means at the same time I am sending in different areas, same signal. But in analog signal you cannot. In analog signal, suppose at the same time if you want to send the same value for three different areas, you have to choose three different times. You cannot. Okay?
Yes, ma'am.
Clear, everyone? Advantage of digital signal over analog signal. There have some difference. Thus, that means till now we have read advantage. That is again, thus the difference between analog and digital is tabular forms in shown above. The combination of analog and digital components is not rare to observe in a circuit. Usually microcontrollers are digital bits and they have interior currently frequently which allows them to connect with analog circuitry, and ADC means analog to digital converter. That means you can use a device that is known ADC, analog to digital converter, for converting your analog signal to digital signal. Basically, we have to use ADC for everywhere. Why? One example is amplifier. Are you have you forget those who did FEDS under me? Can you remember the amplifier, works of amplifier? What does it do? Amplifier amplified the original input. Amplified means it extends. Okay. Suppose I have talked. Very good. Suppose I am talking. The sound is will give input as a analog signal. Okay. Then this sound by the ADC you can change as a digital signal. Permits to microcontroller to connect an analog sensor to read analog voltage. The fewer general DAC means digital analog converter. Fewer permits a microcontroller for generating analog voltage, which is useful whenever it requires making the sound. What I told. So I am talking and the wavelength is creating, that is analog. Is not it? আমরা সবাই জানি যে আমরা যখন কথা বলি এখানে কথাটা কিসের মাধ্যমে শুনতে পাই? আমরা ছোটবেলা থেকে পড়েছি, তাই না? কথা কিভাবে আমরা শুনতে পাই? সাউন্ড কিভাবে শুনতে পাই?
রেডিও তরঙ্গ।
তরঙ্গ বলি ওটা। তার মানে এখন আমরা পড়ছি সেটা কি? ওয়েভ। তার মানে একটা ওয়েভ ক্রিয়েট হয়। এই ওয়েভটা মিডিয়া কি? ওয়েভে আমার কান থেকে আপনার কানে পৌঁছচ্ছে, আমার মুখ থেকে আপনার কানে পৌঁছচ্ছে। মিডিয়া কি? এয়ার, তাই না? এয়ারে একটা ওয়েভ তৈরি হয়, সেই ওয়েভটা আপনার কানে যেয়ে পৌঁছায়। এখন ডিভাইসে এই কাজটা কিভাবে হয়? যখন আমরা কথা বলি যে ওয়েবটা তৈরি হয় সেটা তো অ্যানালগ ওয়েব, তাই না? সেটা তো আমরা তো ডিজিটাল ওয়েব মুখ থেকে বের করতে পারবো না, তৈরি করতে পারবো না। ইজ নট ইট?
Yes,
আমরা ফার্স্টে পড়েছি না অ্যানালগ ওয়েব ইজ ন্যাচারাল অ্যান্ড ফিজিক্যাল। ফার্স্টে আমরা পড়লাম কিছুক্ষণ আগে।
yes, ma'am.
হ্যাঁ, অ্যানালগ ওয়েব তার মানে ন্যাচারালি আমরা যে সাউন্ড কথা বলছি সেটা হচ্ছে অ্যানালগ। তারপরে এখন আমরা যাই যে ওভার দ্য টেলিফোন, ওভার দ্য ইন্টারনেটে যে আমি কথা বলছি, আমার কথা আপনি শুনতে পাচ্ছেন, কিন্তু আমি যেভাবে কথা বলছি আপনারা সেভাবে এক্স্যাক্টলি লাইক দ্যাট ইউ ক্যান হিয়ার, ইজ নট ইট?
Yes,
But what's happened in between that? In between that, they have a device, they are catching my analog signal, my analog wavelength, then they are converting it as a digital for sending it far away. আপনারা অনেক দূর দূরান্ত থেকে ক্লাস করছেন না এখানে, সারা বাংলাদেশ থেকে সবাই ক্লাস করছেন এখানে, তাই না?
yes, ma'am.
আমি আছি ঢাকায়, অনেকেই অনেক বিভিন্ন এরিয়াতে ছড়িয়ে আছেন, অনেক দূরে না? এখন আমার এই অ্যানালগ সিগন্যালটাকে তো আপনাদের কানে পৌঁছায় দিতে হবে, ইজ নট ইট?
Yes, ma'am.
হ্যাঁ, এখন এর জন্য কি করতে হবে? অ্যানালগ সিগন্যালটাকে আমার ডিভাইস কি করছে? ডিজিটাল সিগন্যালে কনভার্ট করছে। তাহলে আমরা এখানে কি ইউজ করলাম? এডিসি, অ্যানালগ টু ডিজিটাল কনভার্টার। দেন তারপরে কি হচ্ছে? ওই প্রান্তে আপনি যেখানে রিসিভ করছেন ওই সাইডে কি আছে? ওই সাইডে আছে ডিএসি, ডিজিটাল টু অ্যানালগ কনভার্টার। আপনি যে সাইড থেকে রিসিভ করছেন সেই সাইডে আছে ডিজিটাল টু অ্যানালগ কনভার্টার। তো আমার যে ডিজিটাল ওয়েবটা ক্রিয়েট হয়েছে, ডিজিটাল সিগন্যালটা ক্রিয়েট হয়েছে, সেটা আমি ওভার দা এয়ার থ্রো করে দিয়েছি, আপনার ডিভাইস ক্যাচ করে সেটাকে ডিএসি দ্বারা অ্যানালগ করে কনভার্ট করে আপনাকে দিচ্ছে, তাই আপনি আমার ভয়েসটা শুনতে পাচ্ছেন এবং বুঝতে পাচ্ছেন।
Ma'am, then can we say that only human can listen the analog signal and the machine only can understand the digital signal?
Digital signal, yes, but digital signal can be understandable by the machine also. Previously when digital signal was not there, that was working with the analog signal, but that cannot be sent too much long area. Okay, so now we have to justify which one is better signal, analog or digital. Based on, so they have a question for you based on the previous all the concepts. Then you will justify the which one is better, analog or digital signal. So homework for everyone, write it in your script that you will read analog signal and digital signal, then you will write a judgment by your own language. Clear everyone?
Ma'am, please repeat.
The question is, can you see the bold mark? This is the question. Write it. You will read about digital signal and analog signal, then you will write your own justification and you have to show the logic why you are telling this one is better. Someone may tell that analog signal is better. Always digital signal will be better, that is not the issue. Is not it?
Yes, ma'am.
So, if you say which one you will say, you have to justify by your logic. Okay?
Got it, ma'am.
And that should be your own language. Should not copy from others or should not match with others' concept. Okay?
Sure, ma'am.
So prepare this homework. Anytime I can say to submit as an assignment this one. Clear? And when till then our group is not ready, that times I cannot provide this slide. Okay? When our group will be ready, I will provide this slide. So the share all the work will goes to you. So this is the end of our class. So they have written the difference between all these things. So everyone now be ready for the class attendance. And do you have any question regarding today's class?
No, ma'am.
No, ma'am.